Okay, so we were talking about actually spawning objects, right? Like so far we haven't like done any of that. Just like all the tools surrounding it for knowing where to spawn them, and all of that, right? But not actually spawning them. So that was the first assignment to spawn item. So one. The second one was to set a random rotation, right? So that was assignment 2. And then we have assignment 3, which was show the prefabs before spawning them, right? So you would have like meshes following around your cursor, right? In the scene view. Okay. All right, let's do it. I'm going to code through these examples or these assignments. And yeah, and as always, just ask questions at any time. Or actually, did you have any specific questions about the assignments? Like if you've worked on them since last time or... So the first thing we need to do is probably set up some sort of prefabs, right? Because now there's literally nothing we can spawn, right? So let's do that. Let's be creative. So what do we want to spawn? I was thinking trees, but it's kind of hard to tell rotation of trees unless we make them very stylized, I guess. Actually, let's make trees. It's a good example, so why not? I'm going to close Grim Cannon because I don't want the cursor thing to... Let's create a material. There we go. There are multiple things that make this... So assignment 3 can get complicated depending on how we implement it. So if we have like, if each object can contain multiple meshes, assignment 3 is going to be more difficult. But if you only have like, if you have one tree mesh and then you just have that, then assignment 3 is going to be a bit more straightforward. But it's probably good to show the more advanced version just so we can get some experience doing that as well. Yeah, because this is going to be made out of multiple meshes now, right? Although it gets more complicated because if we want to involve scale, it might not be a good idea. Maybe that's the interesting part of it. Maybe that makes it more fun. All right, so we need a root object. So we want to place the trees like that. Probably actually want some margin under this as well. Because if it's placed on a curved surface, we probably want it to intersect with the ground as well. Sorry, I was just fiddling with scale because I wanted the root object to have 1 in scale and then everything else can be scaled however, right? Right, and then I want to create some sort of leaves. Oh. Let's just steal these spheres. Remove the collider. There we go. Okay, cool. What a tree. All right, let's make a folder called Prefabs. Gonna put the tree in there. So now there needs to be some way where we can like know what mesh to spawn, right? Because right now there's nothing that you know the cannon doesn't actually know you know what object to spawn. So how do we figure that out? So there are different ways that we can do this. I think one of the easiest ways is to have a field in Grim Cannon for now. We're going to look into how to like load things later, but for now let's add a field to the script of this one. So we've had the serialized properties, so we're going to make another one of those. This time it's going to refer to prefab, which are game objects. So we're going to call that spawn prefab. And it's going to default to null. Then we're going to just do the boilerplate that we usually have to do, just to refer to all of these things. There we go. Create the serialized property. And then we also need to have a property field for this. Okay. So now we should have an assignable field in the Grim Cannon. So now it says non-game object. So now we have this field where you can assign objects. So right now it just says non-game objects. What did you write in onGUI? In onGUI, I added one more property field. So it's the same code as before, but just add one more, and now it's going to refer to the spawn prefab rather than the, the other fields we have. So that's kind of the advantage of property field, that you don't really need to know the type of the property. You can just like shove it in there and everything's going to work, right? So now that we have this spawn prefab here, we can drag objects to it like you would any other field. So you can drag tree onto this one. You might actually also be able to drag scene objects, which we might want to disable. I'm not sure if we can do that here actually, because property field might not have the option to do that. No. Okay, that's fine. So if you do this manually, there's a flag that says disallow scene objects. So if you do editor GUI layout dot object field, this one has a bool for whether or not you should allow scene objects in this one, or if you should just allow assets to be dragged to this one. So right now, this property field, I don't know if there's a way to set that for property fields. It doesn't seem like it, but anyway, there might be. Let's use ignore now. It doesn't really matter. All right, so we can. So now we're referring to this tree, right? So now we actually have some objects to spawn. So now we need to be able to press some button to spawn the things, and I guess that the first step in doing anything like this is sort of figure out, what button do you press to spawn something when Unity already has a lot of buttons that are sort of occupied, right? Yeah. So let's see. What would be a good hotkey? Do you want to go for keyboard or mouse? We could do like if you hold Shift and right click or something, or we can use a key. Not going to use the any key. I feel like that might be a bad idea. I could be wrong though. I've never like used that for spawning items. So Q through T are used. Space. We could use space, yeah. I guess if you press space with no modifiers and the scene view is in focus, it might be okay. Okay, let's go for space for now. I think it might be okay. I guess the one thing we need to be careful of is make sure that if you move the mouse out from the scene view and you type in a field and press space, although that's going to get consumed, so that's fine. So that would probably be during scene GUI, because that's where we want to be able to move the mouse and press stuff, right? So what we want to do, we want to now make it so that when you press space, we want to spawn items, right? So we're in the UI now, so we need to use the input system of the UI, which is not input.getKey, right? So in this case, we're going to check events. So we're going to check if event.current.keycode equals keycode.space. So for now, let's just see if this works at all, right? All right, so let's go scene view, press space, and we get 4 spawn events. Because if I hold this, it just says spawn all over. Okay. So we also need to check the type of the event, because I do believe that this one is getting the held and released events and the all of those things, right? So one thing that can be pretty useful sometimes is if you want to check how the event system works, you can actually log the current event. So you can do event.current.type and then just print that. So I can go back and clear. So now we can see that we have several events here. We have, oh, there is no key held. Okay, so there is layout and key down and key up. Those are the events we're getting. Okay, so in this case, we just want key down, right? Type equals key down. And I'm still not sure why Ryder is suggesting the deprecated ones, but it's kind of frustrating. So let's go back, clear, key down. We're only, oh, so if we hold it, we'll get multiple ones. Right, because the UI event system works kind of like text input, right? If you have a text input field and you press space, you get one and then it repeats, right? So that we're getting the same behavior in the during scene GUI function. I don't know if there's, so I guess if you want to set this up manually, you could like, I guess like check for key up. But I worry that we're probably going to run into issues of like unbalance, where like if you do key down, but you release it in some other window. Yeah. So if you look here, we never got a key up event. So even if we check for key up, we wouldn't actually get that key up event. If you press in this window and release in another window, then key up is just not going to be there. There might be ways of working around that. I don't know. We can also like check focus. I think there's like, I don't know if there's actually a focus in scene view. You can force focus it, but I don't know if you can check if it's focused. Anyway, but I think this is okay for now, where it doesn't like spam it. You can still press and it doesn't like spam it unless you hold it for a long time. But hey, maybe that's a feature, you know? Maybe if you want to spam spawn stuff, there you go. You got spam spawning. All right, so now we got a button we can press to spawn stuff, right? So maybe we should make this into like a function. So void spawn objects. So now oh, actually, there's one more thing we need to check. We're not null checking right now. So if spawn prefab is null, we shouldn't be able to spawn anything, right? So maybe we should call this try spawn objects. And then if spawn prefab is null, then we just return. Oh, I guess I didn't rename it. There we go. Actually, do we have the spawn points? I guess we don't really do. So right now, the way to get the spawn points is that we kind of shoved all of that code into the during scene GUI, right? Those are the ring points. Yeah. Okay, neat. So we need to refactor a little bit. So I guess the first thing we should do is that we need to make a function now so that we can get the points at which we want to spawn items, both in the during scene UI, as well as when you're actually spawning objects. I guess we could call the function and save the points here, and then pass them into this one, and then also pass them into the drawing function, right? I guess that might be... I was thinking of like separating them and call it twice, but that's kind of unnecessary. But it's kind of clean to separate it anyway, so let's separate it. So the first raycast here is going to be to check that we have any valid position that the cursor is hitting, right? So if this raycast is valid, then we're hitting the surface, but if it's outside, we shouldn't be able to spawn anything, right? So we need to make sure that that is valid first, right? Let's see, let's move a few of these things around. Hello, Thor. Yeah, because radius and all of that stuff has to happen before, because then all of these points are going to change. So spawning objects should actually be kind of at the very end, because then we've done all the stuff that we need to do. Okay, cool. So this is where we're actually setting up the points that we're drawing, right? So these are all the individual raycasts for the random points that we then draw a sphere at, and then we draw a line. So these are the points we want. So I guess for now, I think the maybe, I don't know if we should make a type for this or if we should just use raycast hit. Probably we can just use raycast hit for now. So should probably be a list. Wait, excuse me? Because I'm making it a list because they can actually miss, right? So if individual rays miss the surface, then we don't want to spawn anything there. And we don't want like null entries in this one. So if this raycast hits, we're gonna save that to the list. So we just do hit points add, and then the point we hit. Then the drawing functions, we can leave them there. It's kind of weird to like have the drawing function embedded, but it's fine. All right, so now we should have all the points we hit along with the normal and all of that data, right? So now we need to actually check for spawning these objects, which is here. And then we can pass the list into this one. Just want to make sure that this works because we might be running into some like UI event issues. It still says spawn. Okay, good. Okay, so now I want to create these objects. So, all right, so iterate through each point. So that would be for each raycast hit and hit points. Then we want to spawn prefab, right? So there are various ways of spawning objects, right? You are probably mostly familiar with instantiate, right? Right, I should just call everything instantiate because spawn has a different meaning, but so I'm going to use that word. So we want to instantiate this prefab, right? That's the thing we selected. And then, as usual, you set the position and the rotation, right? Excuse me. So the position would be the hit points hit dot point. And then the rotation of this one, that's going to be a little bit more complicated because it's ambiguous, right? There's no one rotation that's quote unquote correct for this. So for now we can do a look rotation. Quaternion dot look rotation. What is Thor up to? Look at that Thor. He's in a box. Thor is on camera right now. Important content. Okay. Right, so then we also need to set the rotation of this object. Let's actually cache that because this is a long line. Quaternion dot look rotation, and then we want to give it a forward vector and an up vector, right? So the easy thing we can do is just do hit points dot normal. Right, sorry, hit dot normal, and then use the world up vector as the reference vector. So this is going to have some issues, but we're going to solve that. So let's first do the instantiation, and then we assign the rotation here. All right. So now we're using instantiates, and this is again the wrong way of doing it because we're not dealing with undo right now, and this instantiate is actually going to lose the prefab reference. So let's see how this looks. Let's press space, and there we go. So now we have a bunch of trees that fell onto the ground, and they're very sad. They feel so sorry for these trees. They had such a long life. So looking in the hierarchy now, we have a bunch of trees, but they all lost their reference to the original prefab, right? Like none of these are linked. So that's a bad thing, right? We want these to keep their prefab reference. And another issue is that we can't undo this. If I undo, it's just undoing selection, but not the spawning of these things. So now we already have like several problems. So let's solve that. So first off, delete those. Let's see if I can remember this, because I don't actually do this very often. I'm pretty sure it's in Prefab utility. So there's instantiate Prefab. So there we want to refer to, let's see, what are the parameters? It doesn't actually have the position or rotation, but that's fine. Okay, so first off, we need to instantiate this one. So we instantiate spawn prefab. And then we assign that to, we need a reference to that one. That's our spawned thing. Is that an object or, yeah. Right, and then we set its position and rotation. So spawn thing dot transform dot position equals hit dot point. Then we do the same with the rotation. Okay, I do believe this is enough to make it keep the prefab reference. Again, I'm not entirely sure. I could be wrong. There we go. Okay, so now we got the prefab reference linked, right? But I still can't undo this. So yeah, I could undo that I deleted them, but not that I created these old trees. So they're in a weird state right now. And these trees we also need to remove now, and they're also not undoable. Okay, so the thing we need to do now is that we need to go to undo and to call register created object undo. That's the one we need to do. So we need to register that we created this object, right? And then also give that a name, because we need a name for the undo thing, right? When we go to the undo menu, it should say, you know, undo spawn objects, right? Okay. Recompile. Let's see if we can space and then undo. There we go. So now we can place a few trees. And then we can undo that. Neat. Yeah. This looks really weird. This is a whole aesthetic, I must say. It looks like a forest where the logs pointing out of the forest. All right. So there are a few problems, right? Like all the trees have fallen down, which is not great. So we need to make them not fall down. So this is quite often because when you're in tangent space, I don't know if you remember, we talked a little bit about tangent space. So if you have a surface, imagine these being like rolling hills or whatever. If you have something that is pointed directly out from the surface, then that is usually the z-axis in tangent space, right? So tangent space is sort of a local space for a given point on a surface. So usually the z-axis is the one pointing out from the surface, and then the let's see, I just want to make sure I draw these correctly. And then the tangent of a surface is going to be perpendicular to that one. That's usually x, the tangent, and then the bitangent is usually the y component. But when you're placing objects in the world, like our trees, for instance, our trees are not oriented that way, right? Our trees have y up. So that's the discrepancy we have, right? So the trees are aligned with y up, which means that the z-axis is going like this, and then the x-axis is pointing toward the camera here, right? Okay, so basically what we need to do is that if we look at this transform, then since the tree is pointing in the y direction, the tree is going to lie down along this thing, right? So we need to do a rotation that rotates it up onto the z-axis, right? So we didn't actually talk that much about rotations when we had our math class. So I figured this would be like a good opportunity to see like an example of how you could use rotations. So given that we now have this rotation, that is, you know, that's the rotation we have here. We've sort of created a tangent space here. So, or a tangent space rotation, but now we need to modify that one. So first let's do quaternion rotation equals that, and then we assign the rotation. So now basically what we want to do, we want to take this quaternion, rotate it by 90 degrees around the x-axis, right? So we got the x-axis here, and we want to make a positive rotation around the x-axis. If you want like a good like thing you can keep in mind to figure out, you know, what direction do you need to rotate in, a useful thing in Unity, or sort of in math in general, but it kind of depends. So Unity is a left-handed coordinate system, meaning that if you have your left hand, you have x, y, and z, and they're all perpendicular, right? So that's, I'm holding up my left hand, and that's why that works, right? So it would be like that, right? And if you want to figure out, you know, what direction does something rotate in a left-handed coordinate system, you can use your left hand, and if you curl your fingers and hold your thumb up like this, sort of like a thumbs up, if you imagine an axis being your thumb, the curl of your finger is the positive rotation. So if I hold this one with my thumb pointing in the y-axis, my fingers are pointing in a positive rotation. So that's a pretty useful like guideline for figuring out, you know, how do things rotate? What's a positive rotation? What's a negative rotation, and so forth. So left hand, thumb is the axis. The curl of your fingers is the positive rotation. So negative rotation would go this way, right? Anyway, super useful thing to keep in mind whenever you're dealing with rotations. And then watch as I get this wrong, probably, even though I just told you all of these things. We'll see how it goes. So theoretically, we should do a positive rotation around the x-axis, right? So if you want to combine rotations with quaternions, then the way you sort of quote unquote add the quaternions together is that you multiply them. That's sort of the equivalent operation of, you know, adding positions together, right? But if you want to do that with rotations, you multiply. So you can do quaternion dot Euler. So that then we can use like an Euler angle representation of this one, but convert it to quaternion. So we wanted a positive rotation around the x-axis by 90 degrees. And Euler is in angles, or in degrees. So there we go. And then we multiply that by this rotation. So now we have one rotation based on tangent space, and then we also rotate it up using this one. So now if we go back, recompile, press space. Some of them are now aligned. That didn't work. Okay, so then it's probably that we need to do this in the other order. So flip those two. I always forget the order in which you need to do these, because I seem to remember that it works differently. There we go. Oh yeah, that's the thing that's important. The order in which you do this, it actually matters. It doesn't do that for like, you know, regular arithmetic if you just have numbers. You know, A multiplied by B is the same thing as B multiplied by A, but that's not true when it comes to quaternions. So that's a good thing to keep in mind, that even though it's multiplying, the order actually matters here. Yeah, so now we got the correct order. So now we can spawn trees, and they're all aligning with the things. So now we can like start making a little forest, a little glade in the middle. Yeah. So there we go. I can also put them on the underside of this one. This looks like a little coronavirus. It should be a parent object. Why? like per click or something, that's probably not something you want. Because then you're kind of adding like more hierarchy than you need, right? And yeah, the more nesting you have in the scene view, the more expensive it's going to be to process all of those objects in there. Yeah, so trees are not in the global hierarchy. Oh, gotcha. Yeah. That is the most performant way of doing it though. But yeah, for organization, you quite often have like some sort of quote unquote folder game object that you then have all the trees under. The proper way of doing it would probably be to have that folder object, and then on build, you remove that object and unparent everything and put it in root. Does it work with occlusion calling though? Yes. Occlusion calling is done per renderer, so that's kind of a separate thing. Doesn't really matter how many, like, your like hierarchy doesn't matter for occlusion calling. Does it matter if you mark the game object as static? I don't think that makes a difference, no. I don't think there's a static type that is related to like game object hierarchy static or something. No, like the static flags don't include anything that I think would refer to that, right? For organization, I saw someone do, oh, game objects in different scenes. Oh, gotcha. Yeah, you could do that too, like multi-load scenes. But yeah, setting it up so that, you know, you have parent objects that you delete on build is not that complicated, actually. You can make the, there's like a callback that's like on, I don't remember what it's called. There's a callback that happens when you build a scene as well as when you press play in a scene. So that would be the same callback that when you build a scene, those things are going to get removed if you tell it to remove that, as well as when you press play, it's also going to call that callback. I don't remember what it's called. It's like post-process scene or pre-process scene or something. Biggest fear of T people? Yeah, that's really frustrating. If you're like working on a game and people are just T-posting in your game, it's like, oh geez, why are my animations not working, you know? It's so frustrating. The next thing is that we're going to set up a random rotation on this, right? So we've done the spawning part, so that's finished now, but we also need the random rotation. Currently, I guess it's kind of hard to tell the orientation of these. Maybe we can make another prop, because that's going to be useful down the line anyway. So this is going to be a rock. This is our rocks are shaped, right? So I want to make this one like a little bit L-shaped so that we can like tell the orientation of this one. And that way we can then work out the orientation of this one and make sure that we can set up an orientation that is actually random in terms of rotating around the normal of this object, right? Okay, how's this rock? Is this rock enough? Cool, we got a rock. Great, so now I guess first off we can make sure that the spawning of the rocks actually works. So let's do the rock. And then, boop. There we go. That is indeed placing rocks. So now we can spawn rocks and whatnot, and now we can start looking at the orientation of these objects, right? So if I now place items, you can see that all of them have sort of the same orientation, right? So it's not really, it looks kind of artificial that they all have this rotation, right? So we would want to randomize this in some way or another, right? Oh, audio's cutting out again? Actually, let's try this. How's this? Is this good? This is going to change depending on what I'm doing, and then I'm going to move the cable more and make it even worse. So now I want to make these objects have a more interesting orientation. So we want to randomize this. So in thinking about all of this orientation stuff, we did two things, right? We rotated around the x-axis. So we rotated around like this disk. I'm not holding my tablet pen right now. For the x-axis to rotate the y-axis to point upwards, right? But then after that, we want to rotate around, after the y-axis is pointing in the up direction, we then want to rotate around that up vector with a random angle, right? So, yeah, so let's go back to our rotation. And this gets a little tricky sometimes because the order in which you do all of these rotations matter quite a lot. We might be able to get away with pushing in a random number here. So I'm going to try it. I'm going to trial and error this for a little bit. I hope that's okay. So first I want a random angle in degrees, right? So float rand angle degrees. So that would be random dot value times 360. All right, and that looks like it does not work, I think. I think we can see the underside of the rock, which is, so then it's probably rotating around the wrong axis, right? Actually, let's go to our rock prefab. I like how the Grim Cannon is currently running. Oh, wrong direction. Making this a little bit easier to debug. It's kind of hard to tell the orientation of the rocks after all, so. Okay, so now we can see the local axes of the rocks, right? So in placing these, this looks very wrong. Okay, so let's make a random rotation out of this then. So then we can do quaternion.Euler, and in this case, it kind of depends on which order we want to do this in. We could either we'd either rotate around the z-axis here after the rotation, right? Or they would be this in this direction here, or we can rotate around the y-axis after the whole thing, right? So it kind of depends on what order we do this, but let's do the y-axis because that's kind of the one we want to rotate around, right? After everything's been transformed, then we want to rotate around the y-axis. So let's do another quaternion Euler, and then we do random angle in degrees on the y-axis and then 0 on the other ones. And then we need to slot this in somewhere. Let's try doing that. And if it doesn't work, we swap the order. That doesn't work either. We might have to group these. It still doesn't work. Well, nothing's working. God damn it. Okay, I'm gonna try a few more things. Swap that to the z-axis. Okay. I think what we learned here is that quaternions are fucky sometimes, and I'm gonna show you another way of doing this that's way easier. Because now we're getting into like nested rotations, which gets messy very quickly. I thought this would work actually, I'm kind of surprised. Let's do another method. So an easier way of doing this, we can restore this to the way it was before. I think I tried that one and it didn't work, I'm pretty sure. Oh wait, I still kept this one. Right, or no, wait, did I? Maybe I didn't. I don't remember anymore. Because that would like mess everything up. Okay, maybe we can try this again. Random rotation, quaternion.Euler. Random angle 0. Because I might have left the random angle there. So could we swap it here then? Oh, there we go. That one works. Okay, we got it. Yeah, okay, so what we learned today is the rotations are messy, and that the order in which you do all of these and whether or not you do these two before you apply this one, like all of that matters. So it can get really messy, as you now have seen. Okay, so now all the up vectors are pointing out from the surface, and the other ones are tangent, and they do seem to be random, right? Don't think I see any patterns in these. Yeah, rotations in general are pretty hard to like wrap your head around, because they act pretty differently to positions in many, many different ways, right? Where if you do, one position plus another, that just works as expected. Like A plus B is the same thing as B plus A, right? But with rotations, it's like completely different. And especially if you have more than two things you want to apply to each other, then there are so many different combinations of that give you different results. And if you don't get that in the correct order, then everything becomes a mess, right? But now we got it to work. So now we can remove our little debug shenanigans in the rock. So now we got our random rotations. Okay, so there's one more random rotation that we're not doing right now, as you might be able to tell, right? So if I place multiple things here, it doesn't actually randomize the like little newts there. That, I guess, is sort of like a design question. Like, how do we want this tool to work? I think for me, I don't think like randomizing that rotation is something I would want, but I think I would want to regenerate the points after placing, right? Then I want to get new random positions, so I don't just like stamp the same pattern one after the other. So that's a pretty quick thing we can just slap in. So there we go. So try spawn objects, and then on successful spawn, we want to randomize the points again, right? Generate random points. And then we probably also, or actually, I was thinking we might need to update the scene view, but I think that's going to happen automatically because they're spawning objects, right? All right, so let's see if that works. There we go. So now it's actually changing every time we spawn objects. Teacher bad. Teacher don't know rotations. Oh, geez. I'm sorry. Okay, next thing might be tricky because now we're going to deal with space transformations again. So the next thing was that we wanted this one to preview the actual things that you're going to place, right? Excuse me. So we can sort of do this step by step. So these objects are kind of complex, right? So I think it's better if we start out by making a more simple prefab. So let's make a capsule and kind of just like leave it like that. It's one object with one mesh filter, right? And then we can remove collider. Default material sounds wonderful. Let's save that as a prefab. We can then refer to that, the capsule. All right, so we should be able to spawn capsules. Look at these little newts. They're so good. I want to put little ice on them, and it looks like they're like extruding out from the grass. Nudes? No, newts. N-O-O-T-S. Jesus. All right, so now we got the capsule, and now we want to draw this, right? The goal is to get a preview of like what would it look like if the objects are placed here, right? Where are we drawing things? Let's see if I can collapse stuff. So that's going to be during the scene GUI. This is where we draw the points and everything, right? So this is where we would draw the mesh as well, right? So how do we do that? There's a built-in function so that you can also draw, you can draw meshes sort of in immediate mode, is what it's called, where you have a call that says draw mesh, and then the mesh is going to be drawn immediately. It doesn't care about rendering pipelines. It doesn't care about frames. It doesn't care about any of that, right? So that's just going to immediately draw to whatever context you have, which we might run into issues with that, and I hope not, but we'll see. So first off, we need to know what is a mesh, right? So to get the mesh, we can go to, that depends on the object. So we need to jump into the object. So that would be spawn prefab dot get component. And the reference to the mesh lies in the mesh filter, right? So that's where we got the capsule. So we want to reach that capsule. So we get component mesh filter and then dot. And then, like I mentioned before, I think it was the first lesson we had, the difference between mesh and shared mesh. In this case, we really don't want to call mesh because then we're going to instantiate that mesh. So we need to make sure that we're calling shared mesh, which is referring to the actual asset of the capsule, right? Which is not in the assets folder because it's a Unity's own model, right? So this gets us the mesh assets. Okay, so now we got the mesh, but then we need to draw this one somewhere, right? So I hope this works. This might get complicated because this is actually a UI call, but we'll see, I guess. So we can do graphics.drawMeshNow. And then we pass in a mesh, which we have. And then we have either a matrix or a position and a rotation. So we can do point hit dot point, and then rotation. We don't have that in here, so we could for now just do quaternion dot look rotation from point hit dot normal. Okay. Hope this works. Recompile. And that sort of works. Okay, I know why this doesn't work. And it's kind of interesting that it does this. So we sort of have some resemblance of capsules here, right? But I think what's happening is that I'm pretty sure that it's using the same shader for this one, or material, as the lines that we're drawing. Because that's kind of the last thing that we were drawing. We drew like an AI anti-alias polyline, right? I'm kind of curious to see if we swap these two to see if the now they're invisible. Okay, cool. That didn't make much of a difference. Okay, so with draw mesh now, we need to tell the current graphics context of what shader to use, and we're not doing that right now. So let's make another public property. Let's call this preview material, and obviously this is not something the user should specify, right? But we're going to do this temporarily so that we can easily assign a material to it. So we got preview material. Let's recompile. Then oh, it's not showing up, and that makes sense. Sorry, I'm just doing the boilerplate now so we can draw the preview material in the UI. There we go. So anyway, preview material, and if I assign blue there, or I can assign anything. Which one's the correct one? I don't know, default material. If we go back to the drawing, the way this works is that we need to tell the graphics rendering and the current context of what shader to use and what pass to use. So there's a very shorthand you can do for that, where you can do preview material dot set pass and then 0. So that means that we're going to pick the first pass inside of this material, and we're going to use that material to draw any following graphics commands. I hope this works now. Or I hope. Okay, there we go. Good. Otherwise, I would have been scared. Yeah, so now we've got our little preview capsules. And these functions in general are very useful in case you want to do stuff where you don't want the overhead of creating, entirely new game objects. And, you need a mesh filter, you need a mesh renderer, and then there's the overhead of having the extra game objects in the scene. And all of that gets kind of expensive after a while. So it's very nice to have sometimes in cases like these, or sometimes even in game, to instead use direct draw calls like this. One thing to keep in mind though is that this one draws immediately, and it doesn't care about anything else. It just draws immediately. So this one does not care about instancing. It doesn't care about batching. It doesn't care about any of that stuff, right? So that's something to keep in mind. It also doesn't do camera calling. So if you call draw mesh now, when it's outside of a camera frustum, it's still going to be drawn and processed, right? It's just not going to be visible. Yeah. We could also get the material from the mesh itself, right? So we could go material, and then mat, and then we do mesh renderer, and then we do shared material, and then we can use that material instead. So now we're going to use the actual material of the object we're drawing, which is the same thing as I was using before, so that's a bad example. If we go to our capsule and assign something else here, brown, there we go. And then go back, now they're brown instead. So it's using the material that we've specified in the mesh now. Okay, so the next thing we should fix is, you can tell that the rotation of these is wrong, right? These are not randomized, but if we hit space, it's going to place them with a different orientation. And it's also going to make them, in this case, these are actually using randomized rotations as well. If you select them, you can see that they're use different orientations, right? And these two happen to have almost exactly the same one. Thanks, rotations. Yeah, so that we need to fix, right? The orientations are just wrong. I think the best way of doing this is that when we generate the points, this is where we should set the rotation, because we want to use the same rotation for the preview drawing that we're also using for the for placement of the actual objects, right? So what we could do is that instead of using raycast hit as our data structure, we could create our own like data structure for that. We could actually use the built-in Unity one. There's a Unity type called pose. So pose is a vector 3 and a quaternion. So it's sort of like an oriented point, right? So that might be useful. I was thinking we could create our own data type, but I don't know if we should do that. Let's use pose for now. So then if this is a list of poses, then we should rename this. So the position is going to be pose.position, and the rotation is going to be inside of the pose. So we're going to calculate that elsewhere now. So now we're going to set that to pose.rotation. So now we're going to move this somewhere else. So now we need to make sure that the pose list is properly like populated. So the hit points is now going to be a list of poses. All right. So this is where we add to the list of points that we hit. So now we need to get the rotation as well here. We just have the position, right? So pose equals new pose. And as position and rotation. So position is going to be point hit dot point. And then we need to calculate the normal or the orientation. So now we can bring back these. So let's replace a few things. This needs to be point hit dot normal. And then we got the rotation. So this is calculate rotation and assign position. Hurry. There we go. I did the words. Then we want to add this pose to the list of the points we hit, right? Let's call this like hit poses. Cool. So so now instead of using the like points here and instead of using look rotation, we can use our poses, right? Actually, let's just make sure this compiles before we do anything else. Just want to make sure the refactor is fine. There we go. Okay. So instead of using point hit, we're instead going to use the post dot position. And instead of making a new look rotation, we're going to do post.rotation. And going back, you can see that these are not oriented, right? They've just flipped to be upright. So now if I press space, it's going to plop them in with the same orientation. And again, the pose is sort of like, it's sort of like a transform without scale that doesn't have the overhead of actually creating a whole transform, right? In this case, we're just using it as a carrier for carrying the position and orientation. But yeah, and it's not like a complex class at all. So if you're in an earlier versions of Unity where you didn't have pose, then you can make your own type that just have the position and a quaternion for the orientation. How do you set up trispawn objects? Trispawn objects like this. So the big difference is that we use post.position and post.rotation here. Actually, is there pose? No. Okay. Great. Then we have the more complex case. So this code is not actually going to work. This doesn't work because we are only reading from the root object, right? We're checking the... So this is where we're drawing the thing. We're just checking the root object, checking for a mesh filter, checking for a mesh renderer, and then we're drawing that one mesh, right? But if we look at the prefabs that we have, like the tree is not just one object, it's a whole hierarchy of objects, right? So that's a problem. We need to make sure that these, we need to make sure that we're actually drawing every single part of this, because the tree is not going to draw at all. The tree is going to get a null reference exception on this line because the root doesn't have an object, right? Okay, so now this gets a little bit more complicated, and I might screw up during this whole thing because I'm not super familiar with using matrices, but we'll see how it goes. Also, I'm skipping everything related to optimization right now, so I'm just gonna like hack this until it works, and then we can optimize later, right? That's generally how I work, but because it's most important to get it up and running first, right? Okay, so what we need to do is that we need to get not only one mesh filter, one mesh renderer, we need to get all of them in an entire hierarchy of each object, right? We can iterate through all of the components in the prefab, right? And now I just remember that this might not actually work, but we'll see how it goes. So we do get components in children, and we get the mesh filter. Mesh filter is kind of the... We can search for either mesh filter or mesh renderer, but we just need every object in the hierarchy that contains a mesh filter, right? Okay. So I think for now, I just want to make sure that this works, because there are some caveats here. Using get components in children on a prefab that doesn't exist in the scene yet means that I'm pretty sure that the objects are themselves disabled. So I'm not sure if this is going to work. So I just want to make sure that this works before anything else. Yeah. Let's just print the amount of mesh filters. Wouldn't it just be easier to have one tree? Yes, it would be. Like if you were in a game, quite often you would have objects that you spawn that are just one mesh, right? And but the problem is that that's not always the case, right? Quite often you have more complex things that you want to spawn that contain multiple meshes. What is my keyword doing? So it's like you kind of want it to be generalizable to something that is more complex than just a single mesh. Yeah, so that's why we're doing this. It's showing a 1 for the capsule, which makes sense because there's only one object. So now let's try the tree. It says 6. Okay, so that works. Perfect. Neat. All right, so now we got the mesh filters, right? So what else do we need? We need the meshes that are in these, right? So we need another array of meshes. Actually, we can make the for loop immediately here. So iterate through the mesh filter. So we can get the shared mesh of that one. There's all sorts of stuff we could do here in terms of like, we could add, you know, to make sure that it actually has a mesh, because the mesh could be null and so forth. But I'm just going to skip all of that for now. Okay, so we got the mesh, but we don't have the material, so we need that. That's going to be the same thing we had on here. So we do filter.getComponentMeshRenderer. And then we get the shared material of that one. And then we can draw the mesh. Okay, so we're almost there. So now what we're doing is that we're iterating through all the mesh filters. And for each mesh filter, we get the mesh and the material on the mesh renderer attached to the mesh filter object, right? And then we get the shared material, set the path material, and then draw the mesh. Things get more complicated now, because now the problem is that we are drawing things in the poses position and rotation, right? But that's not actually what we want to do in this case. So if we go back here and recompile, you can see that these are not exactly the trees we were expecting, right? They pop up and become correct once we spawn them, but this drawing function, something's happening here, right? It is picking the correct materials though. You can see that it's got the stem that looks fine, you know. But if we go into these, this is very difficult because they're moving as I move my cursor. And there's a sphere down there, right? So it is drawing a sphere and it is drawing the stem of the tree, but it's drawing them at the wrong position with the wrong scale, right? And probably with the wrong rotation too. Rotation, I guess, doesn't matter that much with these trees because we didn't like rotate any like individual objects. So now we sort of have. Let's illustrate this actually, because this is really, really good to keep in mind when like dealing with any kind of space. Okay, so still, if someone can explain why my Photoshop locks up sometimes, I would be so happy. And now I lost my cursor. There it is. So here's what happens in Photoshop. The document is locked. I can't draw anything here. So that's really weird. I don't know why that happens, but I can make a new document. That works just fine. Like I can even like use my tablet in this document and that works fine, right? But this document is now cursed beyond redemption and I need to close it and reopen it for that to work. How the heck can that happen? Like how can a single document get locked? And it's also incredibly difficult to Google for because I just find like how Photoshop gets locked. I'm like, why is my Photoshop stuck? And it's like, but that's not the problem. I can even save the document. Where were we? Right, we were looking at the trees just didn't work at all, right? They look completely broken. So the problem is that we have this point, right? We want to place a mesh here and then we're orienting it with the surface and all of that stuff. And then we're drawing it. So in this case, we're drawing the stem of the tree, which is the cylinder. And then we're drawing the sphere. That is all the different things in the treetop, right? All of those are being drawn here as well. So what we need to take into account is the local position of each of these objects, right? Because this in and of itself is a space, right? We have a space for each mesh. And, you know, so each mesh, hold on, did I get my orientations right? I could. So if you have the spheres and the treetops, these have an actual local position, right? They are located within this object right here. And they also have their own scale. So that scale needs to be taken into account too. And then sometimes they would also have a rotation, right? So now we have these three things that can happen to an individual mesh or an object within each of these things, right? So we can do this sort of step by step. First thing we want to do. So every time you talk about some position, orientation, and scale of an object, like if you look at any object in Unity, if I select this sphere, you can see that the transform has a position, a rotation, and a scale, right? We haven't talked about this a lot. I don't think we even mentioned it in the math class that we had. But the way that you store this data, the way you store a rotation, a position, and a scale is internally in the engine, and even in rendering and in almost every single like aspect of game development, you use matrices to store that data. Sometimes they're called, in this case, they're used as transformation matrices. So let's see, well, what is the structure of a matrix? Usually it's stored in a 4x4 matrix. It's got 4 rows and 4 columns. This can be used to store all of this data that we just talked about. Quite often, you know, you use quaternions for your rotations and vector 3s for your position. In this case, it works slightly differently. So, you know, we have talked quite a lot about basis vectors, right? We have some x-axis, we have some y-axis, and you have some z-axis, right? The way rotations generally are stored in matrices is that instead of saving a quaternion, it saves the direction of each of these axes. So the way that works is that if you can imagine these three, that's the direction of the x-axis. So if we want to make an x-axis direction, we could do 1, 0, 0. So now this one is pointing in the x-axis direction, right? These are sort of XYZ components for this vector. So if we rotate this one, if we rotate this whole thing in that direction so that x is pointing in this way instead, then it would be 0, 1, 0 for the x-axis of that component, right? So if you want to do something called the identity matrix, or like a transformation that doesn't do anything, then you would have an identity matrix where the x-axis is 1, 0, 0. The y-axis is 0, 1, because this is the pointing up, right? And the z-axis would be 0, 0, 1. So this whole thing completely describes the orientation of the object. Because what we're getting is that we have, you know, every single axis is now fully described as a direction vector, right? Isn't that neat that you can like stir that like that? The next thing is the position of this whole thing, right? If you have a world space coordinate, if you want this position, then that's the vector going from the world center to the origin of this object, right? That would be this vector. So that vector in and of itself is usually stored as a column in the last part here. This is the x component, which would be, all of these would be 0 in case it's an identity matrix, right? But crucially, we need to remember that, you know, this whole section is the position. And then finally, I think quite often game engines cut off this last part. They skip this row. So you can use a 4x3 or 3x4 matrix to save your data. This whole chunk here is the rotation, right? But we don't have a scale. You can bake scale into the axes. So for instance, if you replace this one with a 2, then any transformation you're going to do with this matrix is going to be scaled on the x-axis. And then these are probably left at 0. The really cool thing about using this type of matrix is that you can multiply matrices together. And what you're going to get is a combined transformation of one space into another space. And that is really, really powerful. So these types of matrices are used absolutely everywhere, especially if you're doing rendering. Anytime you render a mesh, then that mesh has a matrix for how it transforms into world space. So that would be, you know, a local to world transformation. In rendering, you have the view matrix, the projection matrix, the model matrix, all of that stuff, right? I mean, you can use these to convert between different spaces. This is sort of what a transform does, right? The transform component is sort of the component-based or game object version of a transformation matrix, which is probably why it's called a transform. If you're going to transform a vector versus transform a position, then you need to be careful how you do multiplications with these. So one thing you can do with this matrix, for instance, if you have the matrix of an object, you can multiply a position vector with this matrix, and that will transform that vector from local space to world space. And that's sort of one of the more powerful things about these matrices, that well, I'm going to say simple multiplication, but it's more complicated than just a simple multiplication. But if you multiply matrix with a vector, you are transforming that vector into the space that the matrix describes. If you have a vector and you want to multiply a matrix with that, if you're doing this in shaders, this comes up a lot, where you have a matrix describing some transformation, and then you want to multiply your vector with that. So you want a vector that is transformed by this matrix from some local space to world space, say. If you pass in a vector that is like, I don't know, 0, 1, 0, let's say this is the vector you want to multiply by. If you multiply that by a matrix in shaders, it's going to set the last component. It's going to get swizzled out to a float 4, so 4 component value. It's going to set this to 0 by default, which means that the multiplication math works out in such a way that this is going to transform a vector, not a position. So this one is actually going to ignore these 3 lines, because this one is 0, so all of these are just going to get cancelled out, and they don't, like, they're going to get ignored and multiplied by 0, right? So whatever position the transformation was describing, it's not going to get used in the final transformation. So if you want to transform a position rather than a vector, then you would need to manually set the last component to 1. So quite often, if you're looking at like shader code or something, you quite often see that people make a float 4 out of their position. You know, this would be the W component of X, Y, Z, and W. So if you're doing shader coding or anything, W is one of those like scary letters that you need to handle correctly. It also comes up a lot when you're dealing with clip space and projections. Yeah, it's a scary letter, but keep it in mind. What about the last line? My matrix math is not that great. I think the last line is mostly there to make the vector math work with float 4s. You can do a lot of matrix math using skipping the last line, but then you can't do like a pure mathematical linear transformation. Last line is skewing. I don't think it is skewing because you can skew using these, right? If you skew the basis vectors, if you set the y-axis to this one, you've skewed it. The operation of multiplying 2 matrices together means that you have some description of the space, right? It's a position and an orientation and whatnot. But if you have another matrix and you multiply these together, it's going to be like you're transforming by one space and then by another space. So you could sort of think of this as hierarchies. Like this could be a child object and this could be the parent object. Multiplying these 2 together would give you the full description of transforming the child object into world space, right? Because this one is describing a transformation from local to world. This one is describing the transformation from local to parent. But if we multiply these together, you would get the combined operation of child object to world. That's what we need to do. So what the case we have is that the parent in this case, that's going to be the little cross we see in the center. That's going to be the one that's going to be the parent, right? So we're going to need to describe this in matrix form. And then we're going to need to describe the child positioning in matrix form as well. Then we want to multiply these together, and then we can use that to then finally transform the mesh positions. I might mess this up and I might not get this to work, but I'm pretty sure this should work this way. I just don't do it that often. But we'll see. Because it gets into like details of like, well, is it a local to world matrix or a world to local matrix? And what order do we do these in and so forth? But I think we can fiddle around with it until it works. So the first thing we need to do is to define the parent space, right? Let's see, where do we do that? That would be this pose, right? So we have the pose, but we don't have this in matrix form. I don't know if there's a thing in there. No, okay. So let's make a matrix. So matrix 4x4. And this is going to be the pose matrix, or the parent, whatever we want to call it. So from there, we can do matrix 4x4.trs. TRS is really useful for like constructing matrices, so you don't have to do like all the boilerplate on your own. So TRS means translation, rotation, and scale, right? So in other words, a location, a rotation, and a scale. So all we need to do here is we can take the stuff we have in the posts. So we have post.position, that's our translation, right? And then our rotation, which is post.rotation. And then the scale, which we don't have a scale. We're going to place them with 1, 1, 1 as scale, right? So that's vector 3.1. Cool. So now we're the post matrix, but we don't have the matrix of the object itself, right? And this might get complicated. I just want to make sure. So the way that I was going to solve this might rely on these positions. So I'm not sure if I should deal with that somehow. I guess I can maybe... Okay, for now I'm just going to set these to 0. We can try fixing that later if we're curious to do that. I just want to make sure that they're set to 0. Otherwise I might mess this up. All right, so we have the post matrix, and then we need the matrix of each individual object, right? So how do we do that? Well, we can do filter dot transform. So now we have the transform of the game object that this mesh filter is attached to, right? And the we can get that using, or we're not going to set that, sorry, matrix 4x4. So this is going to be the local matrix. So this is going to be filter dot transform dot, and then we have the two matrices. We have local to world and world to local. I don't know which one we want. I think we want local to world, but I could be wrong. Okay, so now we have the two matrices. We have the post matrix, we have the local matrix, and now we should be able to multiply these together. Final transform, post matrix multiplied by local matrix. Then, instead of using, you know, post opposition and post rotation, we're going to pass the matrix into this one, because that was one of the properties we could use here, right? Yeah, so let's pass in final transform. And then this is probably not going to work, and then we're going to need to swap things out, change this from world to local until it works. So we'll see how it goes. Oh, it actually works immediately. Well, there we go. Heck, I actually know things, it turns out. Neat. Yeah. So there we go. Now we got the actual trees. And they're very excited to see you. They're just like... Brrr. All right. Cool. I'm excited. This worked. I'm happy now because I don't deal with matrices that often. So we could give these more useful names, I guess. So I guess this would be child to world matrix, right? And I think this would be post to world. And this would be child to pose, I think. I think that's it. Who knows? I could be wrong. And then combining them means that it's going to transform from child to world. Yeah. Okay. Neat. So now we have another problem, which you might be able to tell. Okay, should we fix the disco trees? Maybe we should do that. Okay, so the problem with these trees is that we randomize the rotation here, right? And this happens every time we draw in the UI, and we draw in the UI like all the time, right? So this happens so many times. So we just get this like massive clutter. And oh, we can actually switch this out to the rock as well in case we want. Yeah, so that's probably not great, right? So let's fix that. Right, so we don't want to calculate the random rotation here. Instead that would have to be a part of the random points, right? So we want to randomize it when we randomize the points as well. That's when we want a random position and a random rotation, right? So what do we call this type? We should make a custom type for this. Because it's going to contain a point in the disk and a random rotation. It's sort of like a random, like an instance of randomness. I'm not sure if I want to use a tuple because it's frustrating to name them. Also, instead of using tuple tu, did you know that you can actually make tuples without using the tuple type? So you can actually do vector tu and floats, and this is a valid type. Isn't that neat? Aren't tuples great? Pose. So we don't want the full pose of the rotation. We just want the random value because the pose depends on where you're aiming on the ground. But we want these random points to be independent of the actual final rotation of the object, right? Because that should not, the things data we have in here should not relate to the position in the world, right? This should just be the randomized data for how those objects should then act when generating the pose, right? Yeah, we could use the tuple for this. Okay, so we have the position in 2D, because again, these are the random positions within the disk, right? And then we have the random rotation in degrees, right? So you can give these things names if you want. So it's going to be an array of that tuple. But quite often, like you don't always name tuples, and it gets kind of messy if you like try to keep up with naming them everywhere. But yeah, I don't know. Anyway, so you can do this if you want. But I think in this case, it's probably better to have a struct. This looks like out of context. This looks so weird. Is your child a matrix? Call us now for a support line. Okay, so let's return to the random points. So basically what we needed to do was that in addition to our random 2D point in the circle, we needed to also have a random rotation for the angle, right? So I don't know what to call this. This is kind of like difficult. I don't know, Random data is like a terrible name for a type. Do we call it random data, Ashley?
Hell yeah.
Okay, Ashley says hell yeah, so let's go for it.
I have no idea what you asked.
Like having a type called random data seems really weird.
Does it contain random data?
But it's not like random data, it's like... It's random data, not random data.
Miscellaneous.
Yeah, or it is, yeah. Randomized data, instance of randomness saved as data. I don't know.
Datoid.
Datoid. Okay, public vector 2 point in disk, that's a random point. And then we need the random angle, right? Then we can make a constructor for this. So public vector 2, actually let's make this a class. Random data. So we can pass the, actually, I think we don't even need parameters for this, right? So where do we generate the random points? We do random dot inside unit circle, right? Yeah, so we could just have this constructor and say point in disk equals random in unit circle, and then random angle, also need to specify degrees so we don't forget, is random dot value times 360. Okay. Actually, this could be a struct. That's fine. Then we make it a randomize function. Or set random values. So instead of being the vector 2 array, this is not going to be a random data array. And then we go back here. So we do new random data. So this one is now going to be populated by 0 in all of these, right? So we need to randomize them as well. Yeah, we just call set random values on all of them. And that should work. Let's go here. So this is where we iterate through all the random points, but now we want to do random data. So this is our like random data in random points. This should more be like data point, right? And then random data point dot point in disk. Okay, now this should work the same way as before. There should be no change now. I should also delete my tests. Let's open the tool again. All right, we got some errors. Null reference exception. Probably because we don't have a prefab. Yeah. Right, it's trying to show the preview when there is no prefab assigned, right? If spawn prefab is not null, then we want to draw the preview, right? So recompile, clear. Now it seems to work. So now it's showing nothing, and then if I assign some tree, there we go. All right. So it seems to work the same way it did before, where we can place and see it seems to work fine. Right, so now the idea is that the random angle should also be set once, but now it's being set every frame. But we have set it once now, we're just not reading from that value. So every time we draw, we calculate the random angle here, but that's where we're going to change it now. So that's now going to be within the data point, right? The random data point. And it's going to be the random angle in degrees there, right? So if we go back, recompile. Now they're not chaotically spazzing out. And it looks like they have different rotations too. Neat. There's some look rotations happening. The way that we place these things right now feels a little bit wonky, right? Because we're essentially assigning them in the spawn prefab thing in this little window. And it feels like it's okay for sure, but it doesn't feel optimal, right? Like say I want to switch what things I'm spawning, then that involves like looking the thing up in among the assets and like trying to find it and then assigning it here. And then you can like draw all the stuff, right? I don't think that's great. I feel like it should be better than that. So one thing that we haven't really looked into yet is to draw things in the UI of the scene view, right? We've only done like input events and drawing meshes and whatnot, but no UI. So let's do some UI. So I want to draw some UI now. I want to add some buttons where you can click the different prefabs and then you select what prefabs you want to spawn by clicking those buttons. And I want those buttons to appear in the UI in the scene view and not, you know, something that I drag into this little thing down here, right? All right, so let's do that. So it's going to be during scene UI, right? So basically everything down here is drawing the 3D stuff and dealing with all of those types of inputs, right? But we want to draw UI on top of this. So you can do handles.begin GUI and handles.end GUI. So in here, you should be able to draw buttons now. Yeah, so let's try that. Let's do GUI.button and then a position, which is going to be a rectangle. So let's put it in the top left corner with some margin, 100 pixels wide, 20 pixels tall, and then draw a little label. So now we got a button in the top left that you can click and absolutely nothing happens, right? But it still consumes events, right? if I click on, in the scene view, I select items, right? But if I click this button, nothing is selected even underneath this. I am drawing meshes on top of it though, which is pretty cool. And I recommend you to draw 3D meshes on top of your UI. That's neat. So that's again as a side effect of the fact that the when I said that draw mesh now is very instantaneous and it doesn't tie into a render pipeline, this type of stuff is what I mean can happen. Because since you're drawing it immediately, there's no render pipeline that makes sure that it's drawn in the correct order and, you know, none of that stuff. Yeah, so you kind of need to be careful in how you use that and specifically when you call it and in what context. And it happens because we're drawing the button here, and we're drawing the mesh after that, and therefore the mesh is going to be drawn on top of the button. So if we were to swap the button to be under everything, it would work just fine, right? So what we now need to do is that we want to draw the meshes that we have available as buttons, right? So we want to be able to select between the capsule, the rock, and the trees in the UI. And this is where we get into loading assets. And loading assets is something you're probably going to do quite a lot in doing editor tools. And in this case, we want to specifically find these 3 prefabs, right? So one really useful tool, in case you want to like, okay, how do I find items even through code, is to think of how would you find them in the search box. So if I search for, let's see, I'm pretty sure you can do paths, but now I'm not sure. Okay, there we go. So now we got a filter that we can use to find all the prefabs, right? I think even prefabrics. So if you do T and colon, you can search for different types. I'm not sure if you knew this, so maybe I should talk about that first. If you search for T colon and then material, you get all of your materials. If you search for T colon mesh, you find all of your meshes, and I have 0 meshes in this project. And T colon prefab, then you find all your prefabs in the project. So this is a nice way to like get all the prefabs, right? So now this is probably something we shouldn't do during seeing GUI. If we think about it, it's probably fine to search for these objects in onEnable. Maybe we can make it search for all of the prefabs in onFocus as well. But as long as we're making sure not to search for all of these things during an update loop. And during seeing GUI is an update loop, right? So we should probably go to onEnable in this case. So onEnable should then initialize the prefabs that we want to be able to spawn, right? So we can we can make an array out of that. So this is going to be our spawnable prefabs, or spawn prefabs. Actually, let's just call them prefabs because we don't have prefabs in another context here. So we want to populate the prefabs array with the prefabs we can find in the project, right? But we need to make sure that we don't get all the prefabs in the entire project. So let's say we have another rock, but this one is outside of the prefabs folder and it's used for something else. This is our trajectory manager. I don't know. Then we don't want that object to show up in our UI. All right, so how do we find these objects? So now we need to load prefabs, and there's a very useful class called asset database, and this one contains a bunch of different things for finding assets, creating assets, deleting assets, and so forth, right? So asset database is super useful for all of these kinds of stuff. You're probably going to use it a lot in case you do a lot of like asset management. But in this case, we want to find assets, right? And find assets takes a string, and that's the same as your search string. So in find assets, you can search for, in this case, we're going to search for the T column prefab, right? So this is going to find all prefabs in the scene. or in the assets, right? So this is actually a string array. And what this does is that this one finds all the GUIDs of all of these objects. And GUID is a term that you might have heard before. It basically means global unique identifier, where every asset has an ID that is unique across your project. So that's kind of like to make sure that you can refer to assets in various places, and that's going to stay consistent throughout development, right? So that's what this one is loading. So we're not actually getting the prefab objects. So these are not game objects. We're getting, an array of strings, right? So these are the GUIDs. The next thing we need to get is we need to get the paths of all of these. So then we can convert from GUIDs to paths. So let's do that. So we can do GUIDs dot select GUID, and then we do asset database dot GUID to asset path. So now we're converting from that identifier to a path, or it's finding the path of that identifier rather. There we go. Right, and that's going to be singular. Wait, convert to method group? Excuse me? Oh, right, because it's just pass through, so why not? Okay, so now we converted from GUIDs, and then we converted to paths. So now we have the paths to all prefabs. But we didn't actually want all prefabs, right? We can actually try to print this, so we can for each this collection of paths. So we can do debug.log path, right? Oh, I did not want to put the console there. Let's recompile. Now it's going to call onEnable, and you can now see that we have the paths to all of these prefabs, right? Also find capsule, rock, tree, and trajectory manager. So now we're almost there, right? We have the paths to every prefab, but we want to exclude the trajectory manager. So we want to specifically only include those that are in that path. And I think find assets does have it does have a string array for search in folders. So I think we can exclude things using that. I don't know if it's relative to assets, but we'll try. And this is a string array, so Jesus Christ, formatting, please. Okay. Let's see if that works. Folder not found, assets prefabs. So it might just be prefabs in that case. Maybe even without the little slash. Okay. Now we're gonna have to look at the documentation for this. Wait, I thought the documentation was somewhere here. Anyway. Sometimes it's relative to assets, sometimes it's not. So why is this so convoluted? Oh, assets slash folder without slash. Okay, so there we go. That should work. There we go. Okay, so now printed these three. Capsule, rock, and tree. That's exactly what we wanted. If we wanted to, we could also filter the paths. We could filter the paths and be like, okay, if the paths, begins with this path, then we use it. Otherwise, we discard it and so forth, right? Okay. Cool. So now we have the paths to all of these assets. The only thing that's left to do now is to actually load them, because the having the GUID and the path, none of that actually loads all the content in the prefab. So we need to do that as well. And be careful with loading like too many prefabs. If your project is massive, loading every single prefab in your project might be slow, because you might have many different things there. And keep in mind that like if you load a prefab, you're not only loading the data in the prefab, you're loading everything the prefab is referring to. So if you have like really big audio files in a prefab, loading that prefab means that it has to load all of those audio files as well. If you have lots of textures, it's going to load all of those textures and so forth. So it can be more expensive than one might expect. Yeah, just a heads up and make sure that you're a bit careful with that. All right, so now we need to convert from paths to actual objects, right? And we want to assign that to our prefabs. So prefabs, we're going to set that to paths.select. And we're going to use asset database dot load asset add path. And we're going to pass in a game object because we're not loading materials, we're not loading meshes, we're loading prefabs, right? Yeah. Actually, this is path, and then we convert that to an array. Well, I tried to do this thing, but it didn't work. Now it works. Okay. Oh, Writer probably wants us to inline this as well. Enumerate to array? What? What is Writer suggesting? I'm confused. I feel like this is cleaner, but okay. Oh, maybe. Oh, right. It's null checking and populating an existing array instead of making a new array. That's fine. I don't care about that right now. Okay. Any questions about that, by the way? Why is someone posting bullshit in my chat? Please. Do not. Okay, no questions about that. All right, good. Everything's super clear. So now we've loaded the prefabs and the array should now be full of neat little objects. All right. So that happens in onEnable, and the next step is to actually do something with this, right? So we talked about drawing in the UI. So let's go to, so on GUI in this case is the UI of the Grim Cannon script in the editor window, but not the scene view. So that's in here. So we drew this one button, right? And we set up a rectangle for the positioning of that one. Right, so we want to make a for loop to draw a button for each mesh, right? Or for each prefab rather. So we're going to do prefabs.length. Actually, we can do for each. Or I think so. Right, so we're going to draw a button at this location, and then we want the name of the prefab rather than just that text. So we can do prefab.name, and then we want to move this rectangle so we don't like stack all the buttons on the same position, because we're not using GUI layout now, so now we need explicit positioning. So we can do rect.y plus equals rect.height, and then maybe some margin between the buttons. In UI space, the axes are sort of like in a wonky setup where if you have the screen, then the axes are like this. where the x coordinate increases to the right and the y coordinate increases downwards, which is kind of weird. Yeah, so if I do y plus equals, that means moving it downwards, not upwards, which is great and really neat. Isn't it cool how we align things? All right, so let's recompile. There we go. So now I got 3 buttons. It says capsule, rock, and tree. Isn't that neat? It doesn't work though. So now we need to actually make these buttons do something. So as usual, you check if you press them, and that's how you, yeah, see if you press them, you check if this one returns true. So then what we need to do is we do spawn prefab equals the prefab we have in this loop, right? And then let's go back. Now we can press tree, and now we got tree. So we can press a rock, and then we got rock. So we can press capsule, and so forth, right? Isn't that neat?
Why?
Imagine assets. Yeah. Okay. There was one more thing that I wanted to try. I wanted to try using a function that I pretty much never used. But I'm curious to see if it works. So Unity has a built-in function to get the preview of an asset in texture format. And I'm thinking, wouldn't it be cool if we could actually see the prefab in the buttons? So I'm going to try using that. So that's going to be a texture. So let's call it icon. And it's editor utility dot, let's see, I wrote it down. Get asset preview, which doesn't seem to exist. Might be GUI utility. Does it not exist? Did they remove it? Oh, asset preview. It's changed. Okay. Get mini thumbnail. Neat. Get asset preview. And then we'll pass the asset into this one so we can pass the prefab. So now we should get a reference to texture for the preview icon of this object, right? So we probably need to make this button a little bit bigger because now it's very slim and made for text. So let's make it 64 by 64. And let's see, do we have... We do have an image parameter. I wanted to have image and text, so I think we might have to do a new GUI content. And in there we can do both text and image. So do prefab.name and then the texture. Okay. There we go. Might not work. It does work. We have a little tree. It's very small because it's getting squished by the name. All right, let's ignore the name. Let's just do the icons. There we go. Look at those little buttons. Look at this little cat. Eat there. All right. Any questions about the buttons? Or questions about Thor? He's being a grumpy.
Angry.
What?
He's very angry.
He angry. Okay. I don't like where these are placed, but that's a separate thing, I guess. Okay. I changed it so that it's a toggle now instead of, it's a toggle instead of a button, so that's a checkbox. And then I replaced I need to also pass a value into it, as in whether or not it's selected. And it's selected if the prefab equals a spawn prefab, right?
Hey.
That actually worked surprisingly well, because now we get a little checkbox next to it. Neat. that was kind of everything I'd planned to go through today. So the first thing is that we had these like prefabs, right? We had the like tree, looks like a little broccoli. And then we had the, what was the second thing? We had the like rock. And then we had the capsule. So the first one is that you should allow multi-select so that you can select two of these and maybe not the third one or whatever. And then it's going to randomize between these two when placing items. Yeah, so the first one would be to allow multi-select. You can sort of imagine the use case for that being like, you know, placing foliage or something in some terrain. They could be different types of bushes or different types of trees or whatever. Yeah. So that'd be number one. All right, let's do number two. So we had another problem, right? Where the scene view is looking somewhere, right? And then you're shooting a ray and then you hit some object. Let's say there's a sphere here. And then there's a disk that's spawning objects, right? So one of the problems right now is that it generates points inside of this disk, right? And then it shoots a ray like in the same direction that you're looking. And then it probably hits something or it doesn't, right? But one problem is that if you have something that's very far away, it's actually going to hit that with these little points, right? So even though some of them are going to get stopped on, you know, the surface of some object, some of them go way too far, right? So one of the next thing would be to have some distance limit to how far they can get projected, right? This is the camera. Oh, did that make sense, by the way? I hope it made sense. The picture is not super clear, but where are my colors? Number three. Another case is that if you have the ground and then you have a Photoshop document that gets locked up, you can then save that document and open it again. And then the ray is going to hit someplace, right? So you're shooting a ray and it hits some location on the ground. And again, we get the disk where we're spawning things. But let's say there is some sort of overhang somewhere, like there's a cliff or whatever. Then there we go. I think something like that illustrates it better. So if you're then spawning like trees or something, you probably don't want a tree to spawn so that it intersects the ground, right? So the third one is to make sure the items you place fit by height. So to make sure that if there's something that is obstructing the thing that you're going to spawn, make sure that you don't spawn that, right? So don't spawn when they would hit a ceiling. Basically making sure that they vertically fit. So this one doesn't fit, right? Oh, number 4 is actually not needed anymore. Because we accidentally implemented that. I wanted one of them to be like, you could click and drag to like spawn repeatedly. But turns out the input system just does that automatically. So, 4th and final one. We're out of colors. Ah, geez. There are no more colors. Let's find a neat yellow. Yellow is a pretty difficult color. There we go. I think that's a creamy, good yellow. Number 4. How do you draw 4? Number 4 is a little bit more complicated. All right, there we go. There's a little divots of a dice. Number 4, there we go. Well, what a dice. Goal for this one is that we've sort of had this spawn circle, right? And inside of here, we just get random points and then we spawn at those locations, right? But one thing that can be pretty bad with random points is that random points are usually like, they're not uniformly distributed. So if you generate you know, 2 random points, you could get these 2 points. And then somebody might go, but that doesn't look very random. They're kind of close to each other and whatnot. So quite often, you generally want points that are more uniformly distributed, right? Something like this, right? This is actually not really random. This is a pretty like distinct pattern, because this means that, you know, you can see that the goal of these points are sort of to avoid each other, right? The distance between each point is pretty large, but they're kind of uniform across the whole thing. There are different ways of doing that. If you look up stuff like blue noise and stuff like that, that can be used to make a more uniform distribution. But what I'm thinking we can do that sort of simulates that is that we can set up these things so that we place objects, but the objects also have a radius for in which they don't allow other points to be inside of. So this means that every object you spawn is going to have a little radius, and then if you get a random point that's inside someone's radius, it discards that random point and tries to generate a new random point, and so forth. So what this means is that this is going to kind of give a minimum distance, or a maximum, no, wait, minimum distance of where things can spawn, right? So then you're going to end up with things where, you know, these circles aren't touching. They're all like separate. Give objects a radius. Cool. Okay. That's it. Those are the assignments. How does that sound? Does that sound reasonable? And I think if you run out of assignments, I can think of a million different things you could do for Sunday. Because I really want you to get like dedicated time to work on your own as well. Because I've been doing a lot of lectures, and I feel like doing things on your own is like one of the best ways to learn. So yeah. And where the heck is my goddamn layer? There we go. Okay. But then spawning can take an infinite amount of time when point density is already very high. How to avoid this? That's part of the assignment. That's intentional. See? I'm a little sneaky like that. Oh, you missed that was part of the assignment? I intentionally didn't say anything about that. Because I think it's neat that you like discover issues while you're working on things, and then you're like problem solving on your own, which is like it's a lot of what game development is about, right? Is a Discord open for non-students? Nope. Although my Discord is, in case you want to go to my Discord for my streaming stuff. So if you want to go there, there's your link to our Discord. Because I do streaming outside of doing teaching like this. So we have a Discord full of game developers and stuff. So feel free to hang out, ask questions. Is it possible to use the same tools inside editor windows? Yes, that is possible. Or I guess it depends on what you mean by tools. But like pretty much all of this is a run from this editor window. But then we tap into the callbacks of the UI and everything of the scene view to do all of this. I think there's also a difference in students who are like, I don't know, students in high school or whatever, comparing that to students who are in like a vocational education. Like generally, if you're at FutureGames, you're there because you really want to learn this stuff. So on average, people at FutureGames tend to be way more excited and way more like into the things that they're learning, right? So I've noticed that I feel very lucky to work with students who care about the stuff that they do. Otherwise, I would be really frustrated, I think. But yeah. Will you speak about ECS and modern patterns about game development? Probably not. I haven't jumped into ECS because I don't see the use for it right now. Because what I do tends to not be like very performance heavy, and whenever I need to optimize something for performance, I tend to use the job system to multi-thread my stuff, or I push all the stuff over to the GPU and let the GPU handle that stuff. In terms of like lots of objects in my scene, that's generally not a concern that I have. So in the projects I haven't had a need for ECS, and then given that, I feel like I'm not in a good position to like talk about ECS. But then again, I'm very much on the prototyping, rapid iteration, mash your code in quickly and iterate quickly, rather than like being all about design patterns and doing like a top-down structuring of everything before you start, like all of that stuff. So maybe that's just me and the way that I work. Well, in that case, thank you all so much for joining. For you FutureGames students, I'm going to be in your Discord after I've given Thor some attention, and then I'm going to stick around for a bit longer. But other than that, thank you so much for joining the lecture, and hope you have a wonderful day, evening, wherever you happen to be.